Hello, a very good day. So my name is Madan Lakshmanan, I'm like CHANDRAN, and my Matric number is 215414. And so this is my solution for question number 1. So for question number 1, it states that a signal is given by xt, which is being sampled as fs 10 kilohertz, 10 hertz, and consider domain, and it asks us to find the discrete time Fourier transform, which is dtft of the signal. So now I would like to explain about the equation here. So xt equals to 20e 0.1 t ut, whereby ut is actually the unit step function, and the given frequency is 10 hertz. So what's the first step I'm going to do is to find the sampling interval, which is the sampling period, which is ts 1 over it's equivalent to 1 over fs, which is one of them, which I'll get 0.1 seconds. So now in regards to finding the dtft, so we already knew that we already have a signal over here, which is xt. So xt we already gotten, and now we have to convert it into a discrete time signal and to find the sampling at 0.1 second, whereby we already gotten here at 0.1 second of the sampling interval. So from a normal signal to convert into dts with the sampling of 0.1 second, and from there onwards we'll find the dtft. So now from here we have gotten xn, and xn is equivalent to xn ts, which is the general form of finding the dts signal. So what I'll do is I'll just substitute 0.1, which is the sampling interval that I've gotten, which is ts, which eventually I'll get the answer 20 exponential negative 0.01 and un. So for your confirmation, un is actually the unit step function of the equation. Now after we gotten the dts, now we can convert it into the dtft function. So for the dtft function, we can also say it as x omega, which is equivalent to x exponential j omega, which is equivalent to summation towards infinity, while m approaches negative infinity, xn e exponential of negative j omega n, whereby we substitute the equation that we got from the dts signal and substitute it. So from here onwards, we already got the same exponential over here, exponential negative 0.01 n and negative j omega n. So what I'm going to do is just take out this 20 out of this summation, which eventually, since dtft it approaches infinity, so I'm going to use sum of infinity, whereby equals to rn is equivalent to 1 over 1 minus r. So I've substituted this equation over here towards here, whereby I get 20 in bracket 1 over 1 minus the exponential 0.01 and exponential j omega, whereby the final answer that I'm going to get is this answer, which is 20 over 1 minus 20 1 minus e negative 0.01 e negative j omega. So that's part A. And for part B, it said that find the sample signal of xn for x0, 1, 2, 3 at 2 decimal places. So what I'm going to do, it's simple. By using the sample signal which we gotten, so we are going to use the dts signal and substitute all those n's, which is 0, 1, 2 and 3, into this equation to get 20, 19.80, 19.60, 9.40. So this is the answers given. So what I'm going to do is, in terms of xn, in terms of dts, I'm going to label as n equals to 0, so 20, 19.80, 19.60, 9.40. So this is the answer for question B. And for question C, it asks us to represent x3 in a 4-point Fourier transform, dtft. So what I'm going to do here is, k I'm going to label as 0, 1, 2, 3, and n, the number of terms, equals to 4. And the n minus 1 that I'm going to mention is actually n minus 1. So substitute n into here, you get 3. And now for dft, xk is summation. To find the xk, you use n minus 1 and approaches 0, xn e negative to 2 pi kn over n. So the n, the big N is actually the number, total number, and the n is the number of terms. So we substitute into 3, n equals to 0, and substitute the whole equation into this equation right here. So when k equals to 3, so this is the summation that I've done, whereby x0 is e negative 2 by 4, 3 is the k that we've gotten over here, and also the 0 is the number of terms. So eventually we're going to substitute 0, 1, 2, 3 into this summative equation, and the xn I'm going to substitute with the eventual answer that we gotten, which is 20, 19.80, 19.60, 19.40. So eventually I'll get this answer whereby k equals to 0.40 minus 0.40j. And the magnitude of x3 is equivalent to x3. I'm going to find the magnitude, which I'll get 0.566. And to the assumption question that I'm going to make, the assumption made is that the signal is periodic, and for as the DFT consider the signal as a finite length sequence, unlike the DTFT which has infinite sequence. So how do I get it? It's actually based on DFT has a finite sequence whereby it has a fixed number of sequence that is being given of a period of a signal, and DTFT doesn't have a finite sequence whereby it's going to have a infinite sequence. As we mentioned earlier, as we saw earlier, DTFT always has this infinity sign in its equation. So DTFT is infinite, DFT is finite. So now for question number 2, given a discrete time invariant system below, so this is the discrete time, and first question is find the impulse response. So to find the impulse response, what I'm going to do here is to normalize yn into its general form, whereby equals to yn equals to half xn plus 1 over 8 yn minus 1. So this is known as the first order difference equation. So now let xn equals to delta n. So this part here, I'm going to switch it up into a delta n. Xn I'm going to switch to delta n. So yn equals to half delta n plus half 8 yn minus 1. After we've done that, we're going to substitute this the n status. We're going to normalize this equation by substituting n equals to 0, n equals to 1, n equals to 2, and n equals to 2, whereby we can find out the impulse response for the yn. So first yn, when y equals to 0, I already gotten half, and the first one, when n equals to 1, I already got 60, and the n equals to 2, I already gotten y2 equals to 1 over 2, 1 to 8. So now the general form that I've simplified it, so we have simplified this general form into half times with 1 over 8n un, whereby this is also known as the impulse response hn. So with that we gotten here. So this is the impulse response that we have gotten from this equation over here. Now for the second question, they ask if an input signal xn equals to 2 over 3n un is fed into the system, find the system in terms of frequency and time domain. So now in terms of a general perspective, what we can do is that we can use the convolution method, which is yn equals to xn times with hn, which is equivalent to summation of xk minus hn minus k. So the input signal given is xn equals to the equivalent to 2 over 3n un, and yn equals to half 1 over 8n as we got in here, and then the yn is equals to half 2 over 3k bracket 1 over 8n minus k. So this, how do I get 2 over 3 is from the input signal, and the 1 over 8 is from the previous over here, got in here, from the impulse response. The 1 over 8 that I've gotten here is actually from the impulse response over here, 1 over 8. So yeah, that's why it's 1 over 8 n minus k. So that's why. So now So in terms of defining in terms of the frequency domain, I'm going to use Z transform, whereby xz equals to z over a. So by substituting this equation, xz equals to z over z minus 3, and then I'm going to use the convolution method, which is yz equals to xz times hz. So times it, I'm going to get the frequency domain equation of 1 over. Beforehand, I will find the z transformation of hn, the impulse response. So this is the impulse response that we got it. So when you transform this, 1 over 2 z minus 8. So this form is actually derived from this general form over here. So that's why I got in this equation. And then the final answer, I'll substitute everything by using the convolution method, whereby the xz times hz equivalent to, we times these two equations, the input signal and the impulse response, you'll get this output of yz in terms of frequency domain. So yeah, this is the answer. And then for the second, so now they ask us to find in terms of time domain. So in terms of time domain, what I'm going to do is going to use partial fraction, the concept of partial fraction. So are you going to use that equation from the frequency domain, apply here, and then separate into two different fractions, which is a and b, z 2 over 3 minus z minus 1 over 8, and then factorize 1 over 2 over here. So we'll remove and then take this equation times over here, you'll get this type of equation. So I cancel it off the same terms, and you'll get z squared equals to a bracket z minus 1 over 8 plus b bracket z minus 2 over 3. So I just factorize everything until you get two separate equations. And for a plus b equals to 1, how do I get the value 1 here? Because the value of z is over here. The value of z is over here. So we're going to use a plus bz. So since there are common terms here, so we're going to use z over, this is for this z term, and this is for the non-z term. So we're going to equate it into 0 since there's no values here. So a over 8 plus 2b over 3 equals to 0. Then I'm going to use the first equation, represent a. I'm going to substitute here. Whereby I'm going to substitute here, I'm going to get b, which is negative 3 over 13. And then when b equals to negative 3 over 13 is equivalent to 16 out of 13. So the final answer in the time domain is going to be yz is equivalent to 8 over 13 bracket 1 minus z over 3 minus 3 over 26 1 over z minus 1 over 8. But then this is not over yet, because in terms of time domain, we have to inverse this equation into getting into this general form over here, which is the unit response. And then we get over here 1 over 2, z over 20, z over 20 minus 2 over 23, 2 over 3 n un, and I'm going to substitute this into this. I'm going to convert it into this equation, which is 8 over 13, 2 over 3 n un plus 2 minus 3 over 26, 1 over 8 un, which is into the time domain. So that's all from this video, and thank you very much.